Hello everyone, a very good evening to all of you. I hope I'm audible and visible. If not, can anyone confirm it? Okay, so let's wait for 5 to 10 minutes so that everyone can join this session. mute yourself. Okay, so let's start the session. Hello everyone, a very good evening to all of you. I hope I'm audible and visible. Can anyone confirm it?
Yes, ma'am, you're audible.
Okay, I'm visible also?
Yes, ma'am.
Okay, thank you. Okay, so my name is Pooja Verma. I'm PMRF Research Scholar from IIT Kharagpur, and instructor for this course is Professor Shantanu Chattopadhyay from Electrical and Electronics Engineering Department, IIT Kharagpur. This is a week 1 live interactive session on digital circuits. Okay, you can use the chat box for asking and interacting questions, and also I will suggest to please carry one calculator for solving the problem. And also whenever you want to ask anything, if you have any doubt between the presentation, then you can unmute yourself and ask the question. Okay. Okay, so these are the topics which has been covered for this week. I hope all of you have gone through this week video lectures. So first we will go through the some theoretical concepts related to this week, and then we'll solve some problems. Okay, so For this week, the topics has been covered, that is electronics milestone, evaluation of electronic devices, then analog versus digital electronics, then signal types. What are the different types of signal? That is analog signal and digital signals. And then the topic has been covered, digital to analog conversion and analog to digital conversion, because most of the signals in the nature are in analog in nature, and it is very complex to process that signal. So in that time we need to convert in a digital form, because it is very convenient to transmit and understandable for computers. Then common number systems. What are the number systems available for solving some digital related concept? So that is binary, octal, decimal, and hexadecimal. Then conversion of these number systems. For example, like binary to octal, binary to decimal, or binary to hexadecimal, or octal to decimal, octal to hexadecimal. These are the conversions. Then we will come to the negative numbers. Representation of these negative numbers, that is sign and magnitude representation, one's complement representation, and two's complement representation. Then arithmetic operations. These are the some topics which have been covered for this big video lecture. Okay, so the start of the modern electronics era. So modern electronics era has been started in 1947 by the invention of the bipolar transistor. The bipolar transistor has been invented by Brattain and Bardeen. So from there, the evolution in digital electronics or in electronics era has been started, and the evolution in electronic devices has been started the from the vacuum tube, then discrete transistors has been came, then SSI and MSI integrated circuit, that is small scale integration and medium scale integration circuit has been came, then VLSI very large scale integrated surface mount circuits has been came, and after that Murray has been predicted that the number of transistors that will integrated on a die that will grow exponential with the time. So that graph has been shown by her. And then analog versus digital electronics. What is analog and digital electronics? So analog signals are, just a minute. Can you describe more topics from vacuum tubes and transistors? I think vacuum tube and transistor are very old. So how we can describe whatever the topics has been covered in week 1, that will be discussed, or that problem that can be helpful to solving your assignment problems will be discussed here. If you want anything else, then you can message there. I will try to take that one. Okay, I think vacuum tube and transistors are not in your syllabus in detail. If you want to study, I will give you some material or will try to take in this class. Okay. So as we know that most observable are analog, because in nature everything is analog in domain, but more convenient way to represent and transmit information electronically is a digital signal. So that's why we are here to study some digital representation of the signals, how we can convert, and what are the things that can be understand the computer. And the signal types, there are basically two types of signal in nature, that is one analog, which is continuous in nature, and typically the examples of the analog signals are current or voltage. And the digital signal, another one is the digital signals. Digital signals appears in a discrete label, either 1 or 0, in the form of 1 or 0, and that 1 or 0 is also known as a binary numbers or binary signal. that can be utilized only two labels, either 1 or 0. Okay, so this is the analog to digital converter first. So the here what is going on, sorry, this is a one is analog to digital conversion and this another one is a digital to analog conversion. Okay, so in a digital to analog conversion, first we will give the n bit binary input to a system that will be converted in an analog domain in some fashion. Okay, this is a digital to analog converter circuit, and that will give output in a analog. And another one is analog to digital converter, where the input is given as an analog signal that is converted by analog to digital converter, that is called ADC, and then we will get the digital signal. Okay, yeah. Bhavya, we will study about that. What is the resolution or error in a digital representation? We will study in later classes in detail the resolution of the digital representation and how we will calculate the error. Okay. So the next one is a number system. What is a number system and how many types are there? So there are four types of number system are available. That is a binary, octal, decimal, or hexadecimal. So binary number system. So binary number system is represented by 2. The base is 2 and it is represented by 0 or 1. And then it is an octal number system. Octal number system is represented by base 8 and the symbols that are available in binary number system, that is 0 to 7, 0, 1, 2, 3, 4, 5, 6, 7 till 7. Okay, and in decimal number base is 10 and it is represented by 0 to 9 numbers. And then last one is a hexadecimal number. The base of hexadecimal number is 16 and it is represented by first 0 to 9 by 9 numbers, and after that sorry, I'm not well somewhat, so there is a, so after 9 the numbers is been represented by a letters, that is, for example, 10 is represented by A, then 11 will be represented by B, and 12 will be represented by C, and 13 will be represented by D, 14 will be represented by E, and 15 will be represented by F. Okay, so 0 to 9 till 9 it is represented as it is. After that 10 is represented by A, 11 is represented by B, 12 is represented by C, 13 is D, 14 is E, and 15 is F, because the base of hexadecimal number is 16. Okay, so we need to represent the 16 numbers. Next one is the negative numbers. Just a minute, someone is joining. The another one is a negative number. So negative numbers are three types which can be represented. That is, first one is sign, then ones complement, another one is a two's complement. Okay, so in sign magnitude number, we only add an extra sign bit to recognize whether a number is negative or positive. If the last bit or sign bit, for example, in this you can see that is 0, sign bit is 0, then it is a positive number. If it is 1, then it is a negative number. So for example, for number plus 6, the 6 is represented by 0, 0, 1, 1, 0, right? So for sign magnitude, extra bit for sign, so no changes in a magnitude. Okay, so first MSB is 0, so no changes for a positive number, that is 0, 0, 0, 1, 1, 0, 0. And for represented minus 6, it is represented by 1. Extra bit for sign, so there is a changes in a magnitude. Okay, so next is one's complement representation. So one in a one's complement representation, what we are doing for that example, that is a 4 plus 6, it is represented by, if sign bit is 0, so there is a no changes in magnitude. If it is a, if we want to represent as a minus 6, so we have to take the reverse, we have to change 0 to 1 and 1 to 0. Okay, so for one's complement, for a negative number, we have to change 0 to 1 and 1 to 0. For example, here 0 to 1, 0 to 1 and 1 to 0, 1 to 0 and 0 to 1. It's a binary representation of minus 6. Okay, and similarly, next one is 2's complement representation. For a 2's complement representation also, after 1's complement, if that is plus 6, so there will be no change as it is. If it is a minus 6, so first we need to take a ones complement of a number. For example, 0 here, so here 1, 1, 0, 0, 1. Then we need to add in ones complement to 1. Then you will get this binary representation of the minus 6, 1, 1, 0 and 1, 0, 1, 1. Okay, and the range for 2's complement representation is minus 2 to the power n minus 1 to 2 to the power n minus 1 to minus 1. Okay, okay, so these are the some concepts I think you have gone through the video lectures. Okay, someone is asking some, yeah. Then, if there is a specifically given that in the question you need to two complement, yeah, most of the time for positive numbers there is a positive number, there is a no complement. That is also clearly written for negative numbers, that is sign magnitude representing one's complement and two's complement. Yeah, Bhavya, why two's complement is more preferred in binary arithmetic? It is not necessary in a binary arithmetic. Normally, when the question is asked to you to add or subtract in two's complement form, then it is preferred. Most of the time, it is a binary arithmetic. I mean, in a whatever the things available, ones or when the negative numbers are present, then we need to prefer, I think, ones or two's complement. Okay, so let's start the question. Some questions which will be helpful to solving your assignment questions. So question number 1 is, if 93 by 4 is equal to 23, the base of the number system is, what will be the base of a number system? So how you will solve this question? Anyone have any idea? Okay, so I am solving here. you can also solve. So it is given that 93 by 4 is equal to 23 is the base of a number system. So as we need to find out the base, so let's the base of the system is B. So what we need to do? We have to apply in all those the base B in order to find out the base of a number system. Okay. So here what will 9 into B1 plus 3 into B to the power 0. Okay. After that 4 into b to the power 0, right? Because from here it is 3 into, for example, you have gone through the 3 into 2 to the power 0 or 9 when we have studied about the conversions. And here 23, so 2 into b to the power 1 and the 3 into b 0. So here we will find out 9b plus 3 b to the power 0 is 1 and here 4. This is 9 and here 2b plus 3, right? Now 9b plus 3 is equal to 8b plus 12. Now find out the b. 9b minus 8 is equal to 12 minus 3. Okay, so b is equal to 12 minus 3 is 9. 9b minus 8b is b. So b is equal to 9. So correct answer is option D. Okay, have you got this question? Okay, I hope all of you understand this question. Moving to the next question. So D is the correct answer. B is equal to 9. So next one is the value of the base R if 121 base of R is equal to 144 base is 8. Okay, are you solving the questions with me? And what is the name of the number system of base 9? Base 9, then it can be said at a base 9. There are other things are also, it is not, there are 4 number systems are available that has been used by computer, but in a question you can find out in any base. Okay, that is for the solving purpose. That is called base 9. In that case base is 9. Okay, so next one is 121 R is equal to 144 base 8. So what will be the value of R? So let's solve this question. So how you can solve this? As you know that 1 into R to the power, then 2 into R power 1, here 2 plus 1 into R to the power 0, right? Is equal to 1 into 8 to the power 2. Here base is 8. Base is given here. Okay, here base is r, we need to find out. So base is r to the power 0, 2 into r to the power 1 plus 1 into r to the power 2. Now next 1 into 8 to the power 2, 4 into 8 to the power 1 plus 4 into 8 to the power 0. Okay, so here what we will get, r square plus 2r plus 1, r to the power 0 is 1, to 1, and this side 8 8 is 64 plus 32 plus 4. Now find it out. 64, 32 plus 4 is 100, and if you take it in this side, so r squared to r is equal to plus 1, that is 100. So if you take this side, so it is 100 is equal to 0. Now solve this equation, r square plus 2r minus 99. So you can solve it here by this formula. If you find out r is equal to minus b, I think all of you know that this one, b square minus 4ac divided by 2a, right? What is the b here? B is 2. Here nothing is, so it can be taken as a 1. Here 2 is given constant, b is equal to 2 and c is equal to minus 99. Okay, so minus 2 plus minus b square is 4 minus 4 is given, a is 1 multiplied by 1, and what is the c? C is minus 99. Minus 99. Okay, divided by 2a, so 2 only. After that minus 2 plus minus, if you solve this 99 into 4, then and minus minus will be plus, so here you will get 400 divided by 2. After that I am solving this side. Okay, so minus 2 plus minus root of 400 is 20 divided by 2. So if you solve it further, so minus 1 plus minus 10. So if first you will take plus, so you will get 9. If you take minus 10, you will get minus 11. So here two values of r we have got. First one is 9, another one is minus 11. So here it is a minus negative number, so we need to discard it. So r is equal to 9. Okay, so correct option is C. Okay, okay, I hope you all of you have understand this question. So moving to the next question. So next question is, what is the value of this addition? So can anyone add this? So what is a binary addition? 101, then 0 0 1 0 1 is a 6-digit number, and the upper one is a 5-digit number. So concentrate it. So you will get 1, 0, 1, 1, 10, right? 1, 1, and so 1 here, so 1, 1 here, 1 is just adding 1. So 10 again 1 borrow is there, so 10 again 1, 1, 10 and 1 from here, so 11. So here 0, 0 plus 1. So 1, 1, 1, 10 again 1, 1, 10. Okay, so what you have got? 1001100.001. It is a simple binary addition question. So you can match from the answers which option is correct. So option A is the correct answer for this question. Okay. Yeah, someone. Yeah, correct. What is the answer of question? Because I was okay. Answer of questions 2. You can see here. Answer is 9. Option C. If you solve this type like this. Okay. Okay. So moving to the next question. What is the decimal equivalent of 1, 2 to 1 base of 3? What will be the decimal equivalent of this question? So here base is given as a 3. So that means it is a base 3. Okay. So now how you will go? So it is given base 3. Now we have to calculate in base 10. Okay. So how will you calculate this? So 1 into, I am starting from this side. You have to start from this side, but we have to move in the leftward. Yeah. So here 0, 1, 2, 3. Okay. So 2 into base is 3. So that's why we are taking is at a base 2 plus 2 into 3 to the power 1 plus 1 into 3 to the power 0. So 3, 3, 3, 327 plus 9 into 2, 18 plus 3 to the power 1 is 3, 3 to the 6. Here 3 to the 0 is 1, so 1. Okay. So now if you add this, you will get 52. 52 base 10. Okay. The correct option is C. C is the correct option. Okay. Okay. So moving to the next question. Question number 5. So what is the answer of the following additions in hexadecimal number system? So what will be the addition in the hexadecimal number system? So how you will add in a hexadecimal number system? First thing, there are two ways to convert directly from directly. Here you can calculate, otherwise you can convert in the binary, then calculate, add this one and then again convert in the hexadecimal number. Okay, so here I am calculating it directly. You can calculate in another way also. Okay, by converting this number in a binary. If you want, I can show that one also. 6e plus c 5. These both are in hexadecimal number system. So as we know that E is represented by which number? Can anyone tell me in the chat box? E is represented by which number in a hexadecimal form? And what is the representation for C? For C, it is a for 12 and for E it is a 14. Yeah, right. Yeah. Someone is, you can ask it. Yeah, right. For E it is a 14, that is 14, and for C it is 12. Okay, so now add this. So E is 14, 14 plus 5 is 19, right? 14 plus 5 is 19, but after 15, till 15 we have in a hexadecimal number, but after 15 we have to start it again. You have seen in that table where sir has described in one place. Again, after for 16 it is represented as 0, and for 17 it will be the 1, for 18 it will be the 2, and for 19 it will be the 3. So there will be 3 and 1 borrow will be here. Again, now C plus 6. C is 12, 6 is 12 plus 6 is 18, right? So after 15, there is no representation. So again, for 16 here, for 18 is 2, right? 2 plus 1 borrow is 3, and again there is a 1 borrow after that. So 133 base of 16 it will come. Okay. Yeah, E plus 5 is 3 is like that. So E is 14, right? E is represented by a 14. So when you will add 14 plus 5, it is 19. Okay, but in a hexadecimal number, we have representation till F. That is F is equal to 15. Here it is given hexadecimal number system. The following addition we have to do in hexadecimal number system. So till 15 we have the numbers, but after 15 we have to start it from again. So for 16 we have to take 0, and for 17 you can take 1, for 18 2, 19 3. Okay, so it is like this. So for 19 it is 3, and as we are going above 15, so 1 borrow is there. Okay, 6 plus C. C is 12, as we know that C is represented by 12 plus 6. If you add 12 plus 6, 18. So again, after 15, 16 is represented by 0, 17 is represented by 1, 18 is represented by 2. Okay, 2 it is, and 1 borrow is 3, and again 1 borrow is this side. If you are not understanding, you can do one more thing. Convert these in a binary number system, and then again add it and convert it. So, okay, we can do it here. So 6 is represented by which number? 0, 1, 1, 0, right? And E is represented, E is 14, so 14 is, what is the binary representation of 14? 1, 0, right? It is a representation, binary representation of 14. 110. So 8, 4, 2, 1. 8, 4, 12 to 14. Right? Now we have converted 6e in a binary number. Again convert C5 in a binary. C is 12. C is 12. Okay, so 12 represent, what is the 12 representation for 12? 1, 1, 0, 0, right? 8, 4, 12. And for 5, what is 5 represented by? 0, 1, 0, 1. Okay, now add it 1, 1, 1, 1, 0. Again 1, 1, 0. Here borrow is 1, 1, 0, 1. Here 1, 1, 1, 0. Again 1, 1, 0, 1. Here 1 is, so again convert in hexadecimal number system. So what you will get? Here 1 is here, because if you add 3 zeros here, so 1. And what is the representation of 0, 0, 1, 1? Is 0, 3. It is also 3 if you convert. So it is a hexadecimal. So option C is the correct answer. Have you got this question? I think, have you understand now? There are two ways of solving this question. One is directly you can add, otherwise you can convert it into the binary number, then you can add. Why was there carry above 6 plus C? When you are adding E plus 5 after 15, I have told you after 15, what we have to again start from, so there is a one carry na, in a, because in a hexadecimal number there is a representation till 15, but after 15, for example, if you add 1 0 in a binary number, so 1 1, when you carry forward 1 carry, because 1 1 is 10. In a binary after 15, when you are in, there is a 1 carry will be there. Okay. Okay, so moving to the next question. Yeah, someone is raising hand. Yeah, you can ask if you want to. Yeah, Narmada, you can ask in a chat box. Otherwise, you can unmute yourself and ask questions. Okay, so next question is, which if the following is hexadecimal equivalent of 2598.675 base of 10, what is a hexadecimal equivalent of this number? So how you convert it decimal to hexadecimal? So how will you convert this? So everyone is, many of you are continuously joining this session. How can I continue with this? Okay. So how you will convert this? 2598.0675. So can, yeah, correct. Divide by 16 for integers and multiplied by 16 for fractions. Yeah, you can do in a both way. So here is a decimal number is given. Here, so you have to convert it into a hexadecimal. So now what you need to do? It is an integer number. So for that we have to divide it by 16. 2598, and for fractions we have to multiply it by 16, right, as already told in the classes. So what you will get? 16, 25, so 1. Here after that, what you will get? 16. That's why I have told you carry one calculator to solving these type of questions. Okay. So 9 here 99. You will get 99. So 6 and then 2. Borrow here carry is 6 will left. So when you will multiply these two numbers and add with this, you will get this number. Okay. Always remember. When you multiply these two numbers and add with this, you will get this number. So always cross check. Okay. Here I am solving because already solved. You can, yeah, it is allowed, or you can get online COILC 1 into 0. Then how 2. Okay. So how you will cross 16 into 10? 160 plus 2. 162. Always check with this one. Multiplied by this, add with this. Now again 16 to it will not go at any rate. So it will be 10. So from here, from the integer part, what you will get? 10 to 6, right? And what is the representation for 10? That is a, right? A to 6. It is for integer part. Now we have to calculate in a fraction part. So 0.675 multiplied by 16. Okay. So when you will multiply, you will get 10.8. Okay. Now discard this and take it for that purpose, and now you will get 0.8 again multiplied by 16. You will get, what you will get? 16 multiplied by 8, that is 12.8 if you calculate it. Again discard this 12 for the fraction part, and again you will get 0.8 only. Again multiplied by 0.8. Again you will get 12.8. Again it is coming 12.8, 12.8. So you can end it here. So what you are getting from the fraction part? First is 10, and then 12, then 12, then 12. You will get 12, 12, 12. So what is the representation for 10? That is A, and for 12 it is a C, right, in a hexadecimal form. So fraction, the decimal hexadecimal representation of this fraction part is ACC. So overall representation for this decimal number into a hexadecimal is A 2 6 point A C C C. Again, you here in a answer it is given only 4 points, so you can write it in a 4. Otherwise, you can continue it. Okay. So it is a hexadecimal representation of this decimal number. Okay. So what is the correct answer? Correct answer is B. So now you have understand that how you can solve this type of question, decimal to hexadecimal conversion. Okay. So I hope all of you have got this question. So moving to the next question. So next, question number 7 is in sign magnitude of the decimal equivalent of. What is the decimal equivalent of this binary number? Okay, so what is the number? 1 1 0 1 0 1 0. Okay, so from here we can see that the MSB is 1, that means it is a negative number. Okay, MSB is 1, so that means it is a negative number. Okay, just confirm, check it. whether it is a positive number or negative number. So MSV is 1. So it is a negative number. Okay. So now if we need to find it out, so how you can find the decimal equivalent of this number? So first check MSB. It is 1. So that means it is a negative number. Now if you remove this one, that one, then 0, 1, 0, 1, 0. What will be the decimal number of this? Just check it. What will be the decimal number of this? So let's, yeah, someone is asking something. Yeah, decimal number of that representation is 42. Just calculate it. So 0 into 2 to the power 0 plus 1 into 2 to the power 1 plus, let's do from this side, 0 into 2 to the power plus 1 into 2 to the power 0, 1, 2, 0, 1, 2, 3, 4, 5. So then it will be 5, then 4, 1, 0, 1. It will be the 3. Then here one place is missing, so I am writing like this: 0 into 2 to the power 2. Then again you need to come there, then it will be completed. So what will be 2 to the power 5? 32. Plus here 0 into multiplied 2 to the power 4, so always 0. Then again 2 to the power 3 is 8. Multiplication with this, again it is 0. Again 2 to the power 1 into 1, so 2. And 2 to the power 0 is 1 multiplied by 0. So again it is, if you add this, you will get 42. Okay. And here we have discard this magnitude. Magnitude is 1. So it will be the minus 42 base 10. Right? Have you got this? Whenever this type of questions is given, it is written as in sign magnitude. It is not ones complement or twos complement. If you are going to solve this in a ones complement or twos complement, you will get these answers. Okay, you can check it later. So they have not asked for a ones complement or twos complement. So directly just check whether MSB bit is 1 or 0. If 1, then take a negative sign and discard it or take it as a 0, and the remaining numbers just calculate it, the decimal equivalent of this binary number, and take it. They are asking the magnitude only, because in a sign magnitude already we have stated a representation in a negative number. There is a 3 types: sign, ones complement, or twos complement. Okay, so here it is given in a sign magnitude. Okay, so in a sign magnitude, it if MSB bit, last bit in the left side, is 1, then it is taken as a negative number. If it is 0, then it is counted as a positive number. Just check with the video lectures, and in this starting of the presentation I also told that. Okay. Okay, so what is the next question? If mentioned in a question sign magnitude, then only we have to check 1 or 0. Yeah, in a sign magnitude you have to check either 1 or 0. No, if any, it is given 1 or 0. If they are asking for decimal equivalent or addition and subtraction in a question, you will get to know. Okay, here it is written. And if you solve this question by 1's complement or 2's complement, or you can, if you directly calculate the decimal number of this number, you will get something else. Okay, I think 106 you will get because it is if you calculate 2 to the power 6 and multiplied 1 into 2 to the power 6, okay, you will get 106, but it is given in a question in the sign magnitude, so you have to take consider it the first bit. Okay, so just don't confuse it. Someone, if some question directly they have asked, okay, find out the decimal equivalent of the given number, then you can directly calculate. But if it is mentioned, then just check it. Okay, if you want to check it, you can also calculate the 1's complement and 2's complement and then find out the decimal equivalent. You will get this answer and this answer. For 1's complement you will get this one, for 2's complement you will get this one. Okay, so just don't confuse. Okay, so the next question, which of the following statement is not correct? It is given is not correct. Okay, so music on a CD is a digital signal. So music on a CD is digital signal or analog signal? Option B is variation of resistance in light dependent resistor is an analog signal. Option C is human voice is a digital signal. Option D is water tap is an analog signal. So here it is, which option is not correct? So music on a CD is a digital signal. It is correct. Whatever in a CD, whatever signal is stored, it is in digital form. Okay, and variation in a LDR is also an analog signal. Human voice is an analog signal. Okay, whatever in the nature is mostly in analog, so human voice is an analog signal. It is not a digital signal. Water tap is an analog signal. It is correct. The correct option is C. Human voice is not a digital signal. Okay. So as a music, but music is also an analog signal. Whatever I am speaking, it is in analog, but the way it is going to you, that is converting in a digital form. Whatever I am speaking here, it is first in analog, and then it is converted to a analog to digital converter, and it is going to you in an form, analog form. Okay, so it is a way of transmission. Okay, so next question, what is a binary equivalent of this number? So what is a binary equivalent of the decimal number 105.15? How will you convert this one? Yeah, correct. So how will you convert this one? 105.15 in a binary equivalent. So for integer, as already told, for integer part you have to divide by 2, and for fraction part multiplied by 2. So first take the integer part, divide by 2. So what you will get? 5, 2. What left? 1, right? Then 2 again, 6. What left? 0. Again 2, 13. To see there is no left, 0. It is also 0. 2 6 is 12 plus 1, 13. 2 3 is 6, nothing left. So 2 negative 1. Now take it, write it in this way. Now for the fraction part, it is 0.15 multiplied by 2, 0.30, right? This fraction has been taken 0. Now again multiplied by 2, you will get 0.60. You can take it, again multiply 2, so 1.20, right? Yeah. So this fraction will be represented as a binary, again multiplied by 2, so 0.40, again multiplied 0.80, again multiplied 1.60, and these fractions has been taken for representation. Okay, so now write it for the integer part. What you have got? 1 1 0 1 0 1, right? It is for integer part, the binary representation in the integer part, that is 105. And for fraction part, what you have got? 0 0, sorry, just 0.001, again 001, right? So if you write, you will get 1101001 point, after point 00101, right? So just match with the answers, see which one is correct,
001
which option is correct.
B.
Yeah, correct. Option B is the correct answer. 1101 001.001001. Okay, so you have to just divide it integer part and multiply it with the fraction part. Okay, so moving to the next question. So next question is the number 2 to 5.4375. It is a decimal number. Okay, base is 10. In base 4, the number system is equal to. How you will convert the decimal number into a base 4? Now what you need to do? So already told, if there is a decimal number is given, you have to convert it in any base. So in a integer part, you have to divide it and with that base, and in the fraction part you have to multiply it. Okay, so correct, take integer part. I am taking that integer part and divide by 4 because we have to represent it in a base 4. Okay, okay, so just divide it. 4 5 is 20, then 2 left, so 25, 4 6, so 1 left, again take 4, 1 4, nothing left, 4 2 left, again 4, it will no go on, so 3 left, right? So you have got 3201, right? For integer part. Now check on the fraction part. So what is the fraction part? 0.4375 multiplied by 4. So if you multiply, you will get 1.75. Okay. Now here till 2 point it is given. So just we need to check till the 2 point. Okay. Again, after that it is taken for the representation, to discard it again and then multiplied by 4. So you will get 3.00, right? So what is a binary base 4 representation for 0.4375? It is 1, 3. Okay. So now I am writing as a whole. So you have got 3201.13 as a base 4 representation of this decimal number. Okay, so which one is the correct option? Correct option is option B, 3201.13. Okay. Okay, so I hope all of you got this. Moving to the next question. The next question is the fractional binary number 0.11 has a decimal value of. What is a decimal representation of this fraction number 0.12? Sorry, 0.11 is the point. So here it is binary is given. We have to convert it into a decimal. Okay, so already told that after the point or a decimal number we have to represent in -1, -2, -3 like that. Okay, so 1 multiplied by it is a binary representation, so 2 to the power -1 plus 1 into 2 to the power -2. Okay, so 2 to the power -1 can be represented multiplied by 1, so 2 to the power -1 only, so 1 by 2, right? And it is written as 1 by 4. So what you will get? 4, 3. It is a decimal representation of a 0.11. Okay, so option C is the correct answer for this question. Okay, so I hope all of you got it. Yeah. Okay, so moving to the next question. Please repeat question 11. Okay, I will show it. You can just okay, I am showing that 10 and repeating 11. So first I am showing the answer of question number 10. So for question 10, correct option is B. Okay, here decimal number is given. We have to convert it in a base 4. So already told that for the integer part we have to divide it, and for fractional part it is multiplied with. Okay, so option B is the correct answer. And for question 11, okay, they are asking repeat this question. So the fractional binary number 0.11, it is given, it is a binary number. We have to convert it into a decimal number. Okay, so already told you after point from this side we are writing 2 into 2 to the power 0, 2 to the power something, let's see some number 2 to the power 0, 2 to the power 1 multiplying here, but after the decimal this point we have to -1 -2 for a binary represent 2 to the power -1, 2 to the power -2. Okay, so as it is given after the point, so 1 is given, so 1 multiplied by 2 to the power -1 plus 1 into multiplied by minus of 2. So 2 to the power -1 is 1 by 2, right? Multiplied by 1, that is 1 by 2 only. And this one also multiplied by 1, so 2 to 1, 2 to the power -2 is 1 by 4. If you do this, you will get 3 by 4. Have you got this now? Okay, great. Okay, so moving to the next question. The next question is, what is the binary equivalent of the fractional decimal number? What is the binary representation of this decimal number? So decimal number is given as 27.1875. We have to convert it into a binary. So for the integer part, we have to divide it by 2, and for the fractional part, we have to multiply it by 2. So let's do that. 13, 1 is left. Again, when you divide by 2, you will get 1 is left. 3, 0 is left. 2, 1 is left. Again, if you so you cannot divide 1, so 1 is left, right? In the opposite side. Okay, now in the fractional part, what we have to do? 1875 multiplied by 2, right? Just can anyone let me know what is the multiplication of this?
0.375.
Yeah, right. 0.375. Again, if you multiplied it, discard it because it is written in the fraction part. Again, what you will get?
0.75.
0.75, right? Discard it, take it, again multiplied it. What you will get? 1.50. Again, discard it and you will get 1.000, right? Now write it. 1 1 0 1 1 point. What we have got? 0 0 1 1, right? 0 0, we have this is 1 and this 1. So binary representation of this decimal number is 11011.0011. So which one is the correct option? Option B is the correct option. Just check with the option after solving, then tick it. Okay, option B is the correct answer. Okay, someone is asking something. Yeah, it will be shared. The recording of the presentation will be shared. Do we need to require both problem solving session every week? What that it is? It is with both. Which one? I am taking. You can take any one live session. If you want more questions or practice, you can take all the live session. It depends on you. Okay. Okay. So I hope all of you got this question. So moving to the next question. So the next question is an octal to binary conversion. Octal to binary conversion can be accomplished by simply replacing each octal digit by its binary equivalent. How many bits equivalent is equal to a octal representation? Yeah. Can you answer this? Which one is the correct answer? Yeah, correct. 3 bit of a binary number is equal to a octal representation. Okay. So for octal representation, for example, if we want to represent 3 in an octal number system, so how you will represent? You will represent by 0, 1, 1. This is 3 bit number of a binary digit. Okay. So option B is the correct answer. 3-bit representation. Okay, each octal digit is represented by 3 binary equivalent 3-bit. Okay. Okay. The next question is, in 2's complement number system, the range of values for 16-bit number is given as. What is the range of 2's complement number? Where bit is given 16 bit. What will be the range of? So as we know that in a 2's complement number system, the range of a values can be found out by minus 2 to the power n minus 1 to 2 to the power n minus 1 minus 1, right? So here, yeah, correct. So here n is given as 16 because we have to present it in a 16. So just put it 16, 2 to the power 16 minus 1 to 2 to the power 16 minus 1 minus 1. So minus 2 to the power 15 to 2 to the power 15 minus 1. Okay, what is the value of 2 to the power 15? That is, if you calculate, you will get 32,768 to 32,767, because 2 to the power 15 then minus 1. So 32,768 minus 1, you will get 32,767. So in 2's complement number system, the range of a 16-bit number is minus 32,768 to 30 plus 32,767. So which one is the correct option? Option B is the correct answer for this question. Okay. Okay. I hope all of you have got this question. So moving to the next question. Okay. So the next question is, let us consider the following equation in a 6-bit binary number system. That is 6-bit. Okay. So x is equal to a plus b, right? So a is given 0 0 1 0 1 0 in 1's complement binary number system. Okay, a is given as 0 0 1 0 1 0 in 1's complement and b is given 1 1 1 0 1 0 in signed number system. Okay, it is specified here. It is given in 1's complement binary number system. It is in a signed number system. So what would be x? So what would be the x in 2's complement number system? That is a plus b. Okay. So how you will solve this question? So a is given it. What is the decimal equivalent of a? Can anyone tell me what is the decimal equivalent of a? 0 0 1 0 1 0. If you calculate it, you will get 10. And MSB is 0, so it is a positive number. Okay. And B, so it is given as a sign. So MSB is 1, so that means it is a negative number, right? So remove this and count the decimal equivalent of 1 1 0 1 0. So what you will get? If you
26.
Yeah, right, 26, and MSB is 1, so it is a minus 26. Okay, so if you want to calculate in a decimal, so what you will get? a plus b, that means 10 minus 26. It is a one way to solve the problem. I will tell you the other one also. You will get 16. Okay. So now convert in a binary. What is a binary equivalent of 16 or minus 16? Just remember, it is a 6-bit binary number system. Okay. So for 16, it is a binary representation of 16. So we need a 6-bit. So it is a 5 only. So MSB must be 1 because it is a minus. Okay. So it is a value of x. This is a one way of solving this problem. Okay. Yeah, someone is asking, A's value was not mentioned with any sign number. Why did you consider it to be a positive or negative? It is given as a ones complement, right? It is given as a ones complement, but if you want to check, then after 6 bit, just you need to check. The other way to solve this question is take binary representation of this 26 for positive. Okay, so what is a positive 26? 1 1, that is 0 0 0 1 0 1 0, right? And take its ones complement, that is 1 0 0 1 0 1. Okay, yeah, just complete, let me complete it, then I will give you all answers. So it is a ones complement of 26. Now a is also given in a ones complement form, right? So just add this with a, because x is equal to a plus b. So 0 0 1 0 1 0. We will get 1 1 1 1 0 1. Now it is a ones complement of x because we have added a and b. So it is x, ones complement representation of x. Now the question is asked two's complement of a number. Now to convert in a two's complement, we need to add 1. So what you will get? 1 1 0, again 1 1 0, again 1 1 0, again 1 1 0, then 1, then 1, right? Then you will get this. So it is, or this one, it's same. So correct option is option A. Yeah, it is given a complement number, but why to consider with positive or negative number? Because one number is given as a ones complement and other is given as a signed number system, right? When it is given a signed number system, so you have to just check it whether it is a positive number or a negative number. Because if you add directly, it is in ones complement form, another one is a signed number system. So how you will take it? How you will add if there are two numbers in a different form? Okay, second method, can you explain again? Yeah, sure. So here B is given as 11110. Okay, so MSB is 1. So that's why here it is considered as a negative number. So when you count the decimal representation of this number, just I need to. So when you count the decimal representation of this number, remove by this, you will get 26. just check it whether it is coming or not. So more MSB is 1, that's why here I am taking as a minus, because it is written here sign number system. Okay, so now what we need to do, we have to take a positive number, that means 26. Okay, and take, yeah, the thing is sign system is for V. No, only, yeah, correct. Then also to be considered both for sign number system. No, A is given as na here, A is given in a ones complement representation. It is described already na. Exactly what you want to ask, you can yeah, Rohit, what you want to ask, here it is clearly written A is in a ones complement and B is in a signed number system. Okay, and we have to add A and B. These are the in the two different form, right? So already we know that for a signed number system we need to check whether MSB is 0 or 1. So if it is 1, then it is a negative number, and just you need to check, nothing to do. And reviewing by this, just take a decimal number, that is 26, and then take it, or you can just let us, okay, let's 26 as a positive number, the second method, for second method. Okay, so here I have taken positive number, minus 26 is plus 26 to solve this problem. Okay, when we have taken to plus 26, what is a plus 26 representation in a binary? That is 0 1 1 0 1 0. Just check it whether it is coming 26 or not as a positive. Here MSB is positive, sorry 0, so it is a positive. So if you take the decimal number of this, so it is a 20 plus 26 representation. Then A is in ones complement, that's why we are taking the ones complement of the 26 to add this. So just convert it 1 0 to 1, 1 to 0, 1 to 0, 0 to 1, 1 to 0, 0 to 1. Okay, now it is A is ones complement and B is already given in ones complement form. So nothing to do with B. Okay, so add both A and B. So when you will add A and B in a ones complement form, you will get ones complement of A plus B, that is X. Okay, now you have got that A plus B, that is 1 0 1 1 1 1, that it is X, ones complement of X. Now what we need to find, X in 2's complement number system. Okay, so just add 1 for 2's complement. What we need to do, in 1's complement we have to add 1. So here I have added 1 in order to represent the 2's complement of X, that is when you add 1 1 1 0, again 1 carry 1 1 0, again 1 carry 1 1 0, again 1 carry 1 1 0, and here is 0, so carry is added here and 1 is remains. So you will get 1 1 4 times 0. Okay, okay, I hope all you have got this question.
Ma'am,
Yeah,
uh,
yeah,
ma'am, the main thing I would like to ask,
yeah.
whenever we do any of the arithmetic terms, then we have to check the signed condition. That's the point.
See, here it is written already. In the question, it is clearly written whether it is ones complement, sign number or a 2's complement. If it is nothing written, okay, no representation has been given, so just you have to add this. If there is written, for example, it is given as x is equal to a plus in brackets minus b. In that case, you directly can't do the addition because it is given minus b. So what you need to do in order to check it only b, you have to convert in a 2's complement. Then you are able to add. Just practice more and more questions, then you are able to understand. Okay. Have you got this answer? Yeah. Who is asking?
मैम
Yeah.
मैम आपने भी कहा a plus minus of b. So
Yeah.
we have to only convert minus of b to mod b, that is plus b, and then we have to add them.
Hmm. Yeah. There are other questions are there in the upcoming slide. Then I will show there. Okay. Just I am giving that one example. If there are different representations are there. For example, here it is given one number is one's complement, other number is prime number. In that case, you have to check this. Just remember that in a sign number, you have to check MSB is positive or a negative number. If it is 1, then just discard this and take a positive number of that and represent it and add it. Check whether the other number is one's complement, two's complement or sign number. In a sign number, if both are a sign number, you can add that. Okay, directly you can add. If both numbers of one's complement, then you can also directly add. Just see in the question in what form they are asking the answer. Here they are asking answer in a two's complement form. So that's why in the last we need to, it is a direct method. Okay, it is a, you can, so that is a shortcut which I have described in the first one. The second one is the main thing. Have you got who is asking the question? Hello. Okay, I'm not answering. So moving to the next question. If you have any doubt, you can ask. Yeah, you can ask Namrata.
Hello.
Yeah,
Yeah, ma'am, I am Namrata.
yeah.
I think, I'm getting problem in week 2 session.
Week 2 session.
It's floating point and all that.
Okay. So for me, it's a week 1 live interactive session. So for week 2, I will take in the next week.
Okay, fine. Okay, fine.
So what is your query?
What?
What is your query? What you want to ask?
No, it's the floating point I'm not getting, and the derivation of 1's complement and 2's complement.
Okay, floating point and derivation. Okay, I will describe it
Okay, fine.
in a theoretical
Thank
form.
you, ma'am.
Floating derivation. Okay, which time this class end? At 8 o'clock. 6 to 8. I will try to finish as soon as possible. So 5 questions are more left. So let's see. Okay. So what is the octal equivalent of F3V1? What is the octal representation of the F3V1? So how you will represent, it is given in a hexadecimal form. It is given in F3V1, right? class will automatically end at 8, or we can ask question. Yeah, you can ask question after that also if you want to ask. The class timing is 6 to 8, but if the class will not end at 8 o'clock, the questions are left, then I will continue it. Okay, it will not automatically end. And you can ask questions also. So what is a octal representation of the this hexadecimal number system? So first, as we know that it is given in hexadecimal, so first we need to convert into a binary number, because the hexadecimal number representation of a binary number is 4 bit for hexadecimal number representation, and for a octal number it is a 3 bit representation of a binary number, right? So what we need to do, it is given in the 4 bit form, we need to convert into a 3 bit. So what is a hexadecimal number representation, sorry, octal number representation of this hexadecimal number? So what is the binary of the f? What is the representation for f? F is 15.
4 ones.
Yeah, right. 4 1.
1 1 1.
Yeah. And for 3, and what is the number
2
being
1.
allocated?
He is
1010.
11.
Yeah. Now represent the in a binary form. 4 times 1. For
1
15 it
1
is a
1
4.
1.
And for
0 0 1 1.
0 0 1 1, right? And for 11,
11 it is 8 4 2 1. 8 to 10 1 1 0 1 1.
right? And for 1 it is 0 0 0
1 1.
1. Now we have to grouping it in the form of 3 3, right?
3 bits 3 bits.
Yeah, 3 bits 3 bits. What you will get? There is some
4
1
2
2
6
4.
7.
Okay. Yeah, and this is left. So for 0 0 1 it is 1, then it is 7, right? 4 2 6,
7.
it is 1,
Then it's 0 0 1. It's your 1.
it is a 6, right? Next one is also 6, then 1. 0 0 1 1 1 0 is 6, 1 1 0 is also 6, it is 6, it is 6, it is 1, it is 7, it is 1, and this one is 1, right? So it is a octal representation of this hexadecimal number. It is a 171661. So which one is the correct option? For this, option 3 is the correct option. Okay, I hope have you got this? Yeah, option C is the correct answer. Okay, so moving to the next question. Okay, so consider the representation of 6-bit numbers in a 2's complement, 1's complement, and sign and magnitude format. Okay, so in which representation the addition of integers, the addition of these two integers will result in an overflow. So addition of these two numbers in which form, either 1's complement, 2's complement, or sign or magnitude format, overflow will be occur. Overflow means by addition there is an extra bit after 6 bit, because there is a 6 bit number. So after 6 bit, if anything else is there, that is called overflow. So let's check first forward. Let's first take sign and magnitude format. So in a sign and magnitude format, the MSB is 0 0, right, in a both. So that means it is a positive number. So just we need to add, because here we need to show addition of these integers will result in a overflow. So just we need to add these numbers. 0, 0, 0. Again 0, 1, 1, 0, 0, 0. If you add this, what you will get? 0, 0, 0. Right? 1, 1, 10. Again 1, 1, 10, 1, 11. Here 1. Right? If you add these two in a signed form. Okay? Here both are MSP is 0. So here we are considering as a positive number. So just we need to perform the addition, then we will need to show whether overflow will occur or not. Okay. Hello. Hello everyone. Actually my power has been cut, so maybe it will be disconnected in a few minutes. So if I got disconnected, I will complete this in the next class.
When will the next class will occur?
Next Saturday. Okay. Now whenever it is running, I can take till class. After that, if I'm not able to complete it, then so in the sign magnitude form, it is given. Okay, we have added. Now we have to also add in a ones complement form and twos complement form. Yeah, you will get the presentation. You will get the presentation.
Ma'am, the class recording also.
Yeah, class recording is also there. Okay, now what you need to do, you have to check in ones and twos complement form. So first take the ones complement of this number. So what is the ones complement of this number? In a ones complement.
1 0
Okay. 1, 0, 0, triple.
0 1 1 1.
Yeah. 1, double 0, triple 1. And the other number is also same.
That is 1 0 0 1 1 1.
Yeah, right. Other one is also add this 1, 0, 0, 1, 1, 1. If you add this, so 0,
1 1
1.
0 carry 1. 1 1 0 carry 1.
Yeah, you will get this one. Okay. So here 1 after 6 bit there is a 1 carry is there. So that is called overflow. This one. Okay. And now again you have to check in a twos complement form. So what is the twos complement of this number? So just we need to
Just we
add in
have
a
to
ones
add it with
complement.
1.
Yeah. So 0, 0, 0, 1, 0, 1. It is a twos complement of these numbers. 1, 0, 1, 0, 0, 0. It is a twos complement of these two numbers. Just add this 10, 10. So here also overflow occurs. So in ones and twos complement form, the overflow occurs, but in a sign magnitude form, there is a no overflow. So option 2 is correct. Okay, here it is a wrong. So option 2 is correct only. Okay. Okay. So I hope all of you have got this question. So moving to the next question. So next question is the number of digit 1 present in a binary representation of 3 multiplied by 512 plus 5 multiplied by 64 plus 7 multiplied by 8 plus 3. So how many number of digit 1. How many 1 present in this binary representation? Can anyone tell me? So what we need to do, just we need to get the decimal number. First multiply all these numbers and get the decimal number. Then find its binary equivalent in order to get how many ones are present in this for this representation. So 3 multiplied by 512, how much you will get? That is 1536. Just calculate it. Okay. 5 multiplied by 64, what you will get? 320. Okay. What is the multiplication of 7 into 8? 56 plus 3. It is a 320. If you add this, you will get 1915. Okay. So in order to find out number ones, just we need to take its binary representation. So just divide by 2, you will get number of ones. Okay. So it is a 957. 1 left. When you divide again 2, so 4, 7, 8. Again you divide, nothing will left. So 2, 3, 9. Again you will divide. Here 1 will left. 119. Again if you divide it, you will get 59. It will be the 1 only. Again 2, you will get 1, 2, 14. You will left with 1. Again here divide by 2, 7. Nothing will left. 0, 2, 1. So what is the binary representation? 1915. It is a 1 1 1 0 1 1 1 1. 4 times 1, 0 1 1. Right? So how many ones are there? 3, 4, 7 to 9. So 9 ones are in this representation. So option 3 is the correct answer. Okay. There is a one seat shared in a live session. From there you will get the YouTube link, recording session, YouTube link of the recorded session, the presentation link, and other details all. Okay. So have you got this
Where
question?
to post our queries if we have any doubts related to some lectures?
Related to my live session, you can ask directly.
No, live session, the weekly session that are videos that are uploaded.
That I am taking, or the live session one is taken by the faculty, and weekly if I am taking, you can directly ask in the live session.
Okay, ma'am.
Yeah. If you post there, you can question and answer. There is question and answer to query. You can post there also.
Ma'am, no option is showing show there for posting any message.
Okay, I will check and let you know. Okay. So now the next question is find 2's complement of a -9. So can anyone tell me what is a binary representation of -9 or 9? So first we need to find out what is a binary representation of a 9. So it is 1 0 0 1, right? 8 4 2 1. So 8 plus 1 9. Okay. So first we need to find out the, it is given to 2's complement. So first we need to convert it into 1 to 0, 1, 1, 0. It is a 1's complement of plus 9. Okay. Now add 1. So you will get 0, 1, 1, 1. Okay. It is a 2's complement of 9. So here it is given a 8-bit representation. Okay. But for 9 representation, you can add any, that is a 8-bit representation. Okay. So in order to find out to minus 9, so first take plus 9 and find out its binary equivalent. Then 1's complement and 2's complement. Then after finding out the 2's complement, check the MSB bit. Okay. So for MSB, what we need to do, we can put any number of 1s. It will not affect the 2's complement. Okay. So 2's complement representation of a minus 9 is this one, option A. Okay. Because it is asking for minus 9. So you can take it here also 1 1 1, then 1 0, but the number will be the greater. So it's not suggested to take that 4 bit. First take it 9, then 1's complement, 2's complement, then take it like this. Okay, for solving this type of question. Have you got this question?
Yes, ma'am.
Okay. Okay. So moving to the next question. I think 4 times 1, then 0, 4 times 1. It is, you can write, but you have to just check with the options also. Right? 4 times 9, 1, then 0, then 3 times 1. So just check with the 1's and 2's complement. You will get 0, 1, 1, and 0. It's not a 4 times. Just check your answer. No. Okay, so moving to the next question or last question. So the last question is, an 8085 microprocessor executes the following instructions. Two numbers are represented in signed 2's complement form. Okay, it is represented as signed 2's complement form. If q is subtracted from p, that means he is saying that p minus q. Okay, if q is subtracted from p, the value obtained in the signed 2's complement form is what will be the value of that 2's complement form. It is already given two numbers are represented in 2's complement form. That means it is already in 2's complement form. But what we need to do, we need to subtract q from p. Okay. So for we can't perform the directly subtraction. So what we need to do, what we are doing, we are taking the 2's complement of the q, whatever which are going to subtract, then add it into the p. Okay, this is a basic whenever you are going to solve any question like this. So if number is given, so what we need to do, you have to take 2's complement of the what the number we are going to subtract, then add into a p. Okay, so just take it or Directly you can also check whether what it is. I think the correct answer you will not get. You have to match with the answer also. So P is given as 1110111, right? And Q is given 111000110. Okay. So what we need to perform, P plus minus of Q. Okay. So first what we need to do, we need to again take the 2's complement of, I will let you just let me complete this question. This one is the last question. Okay. Take 2's complement of Q, 2's complement of Q. So what is the 2's complement of Q? 0 0 0 1 1 0 0. It is 1 to the 9 10. Here it is a 2's complement of Q, right? So 3 times 0, then 1 1 0 1 0. Now add in P, add in P. So P is 1 1 1 0 1 1 0 1, triple 0 1 1 1 1 0 1 0. So 1 1 1 10 10 10 10 10 1. So discard it. It is called, this is a carry or borrow. You can discard it, and this is a 2's complement of this. So what is the answer? This is option 2. So this type of question is solved like this. If you practice more and more questions, then you will able to get to know how to solve this type of question. Just you have to read the question properly. Okay. So the questions are, and now you can ask your queries, the questions, if you want.
Ma'am, can you just jump to question number 5?
5. Okay. Yes. Yeah. 5.
Ma'am, can you just explain this from the beginning by rubbing if it's possible?
Yeah, sure. So I can let you know from here only. So it is
Ma'am,
given that.
ma'am,
Yeah.
sorry to interrupt. The binary part is clear, that's simple.
Mhm.
But the
Hexadecimal
the
part.
yes, ma'am, the hex part. Yes, ma'am.
Okay. Okay. Let me. So you can do in a both ways. So if you are clear with the binary part, you can solve like this. But okay. So it is given ki addition perform in a hexadecimal. Okay. So one way is convert it into a binary form, then add it, then convert in a binary hexadecimal again. If you want to convert it directly, if you want to add it directly, so you can also add. So what is the binary, the decimal representation of E? Can you tell me?
Ma'am,
What?
E is 14. Yeah.
14.
Yes,
Yeah,
ma'am.
right. Okay,
C is
and
12.
C is 12, right? Here I am getting uh, in the place of E 14 and in the place of C 12, because it is a hexadecimal conversion. So we can't write like 614 or like this. So we have to add like this. So 14 plus 9, how much? 19.
Yeah,
right?
that's 90.
But for hexadecimal representation, what is the last F, right? That is 15, right?
Yes.
But
Yes.
after 15, what we have to do? After 15, again we have to start from the 0 if
Yes.
number is there, right? So for 16, it is how you will present the 16, 0. And for
Yes.
17, it will be 1. For 18, it will be 2. And for 19, it will be 3.
3. Hmm.
But it is after 15, that's why there is a 1 carry. For example, if you are adding 1, 1, ठीक?
Hmm.
It is 0 and you are adding that this carry to the next. So it is hexadecimal number is 16 or base is 16. So after 0 to 15, so there is a 1 carry, right?
Yes, sir.
Yeah. So you got why I am writing here 3, because 19 is represented in the hexadecimal like 3 and 1 carry. And same for 6 plus 12, it is 18.
Can you please explain why we have taken the carry part?
Ma'am, basically the confusing part or something like that is, we have considered the number 19 as 3, right?
Yeah, right.
So we have written 3 as it is, but why would we there carry? Matlab,
Yes, ma'am.
After 16,
yes, ma'am.
after
Ma'am,
16,
basically the
yeah,
sorted part is that we have considered 19,
yeah,
we have considered 3 in the in the place of 19, right?
19, right. But
So,
just understand that after 15, there is the digit which you are going to consider that can carry forward now. After till 15 we can add, okay? But after 15, when you are adding, there will be the one system na? Till 15 you can add, but after 15 when you are adding, you can't add directly. That's why there is a one carry, same as in octal number or decimal number or binary number. Same will be same rule will be followed. When you are in octal number, when you are adding after 8, okay, then for example after in an octal number after 8 or 0 to 7, when it is come to 8, then that 8 we consider as a 0 and 9 will be considered as a 1. It is a number system representation, okay?
yes, ma'am, yes, ma'am.
Just I mean remember this point, because it is hexadecimal number, so you can represent 0 to 15 in an octal number 0 to 7. But after 7 or after 15, when you are adding, you must be adding the to the next. That's why it is a rule. You can check like this. It is a rule. Okay.
The next out,
Okay.
Yeah. What?
yeah, ma'am, that's it. Yeah, this question is sorted.
Yeah.
The last out is from 15th question, question of 15.
15. Okay. Let me 14, 15. Yeah. 15.
So here, ma'am, basically, it was there mentioned that is the one's complement, right?
Yeah.
For the A part,
Yeah.
and in the B part, it was mentioned only the sign number system. But
Yeah.
for the A, we have also considered that the positive or negative, that is the sign number system. So
Okay.
that, yeah,
See, I am just saying that just check the video lecture. Why we are representing sign the number one's complement and two's complement for negative numbers only, to represent the negative numbers in a computer, right? Why we are doing the one's complement or two's complement? Because we want to represent the negative numbers. For example, here it is not given, but in a physical way, if we want to subtract 6 minus 10 and we want to know the computer to do that, we can do, okay, 6 minus 10 is minus 4, right? And now how we are going to understand this to computer? By representing sign there 3 methods are available for sign, ones complement and twos complement, right? That's why here we are checking the MSB bit, whether it is a positive number or negative number. If it is not mentioned anywhere, whether it is a ones complement, twos complement, sign, or any other, it is clearly written only binary number. Okay, it is represented as a binary number, so you can directly add there. If there are two number systems are specified, then you have to check. Not in all the cases. Have
Ma'am,
you
will you
got?
please repeat the last line, the last statement you said?
If it is not given anywhere, it is a ones complement or twos complement or signed complement, then you don't need to check. If it is specified, then you have to check whether it is a positive number or negative number. So it is
Okay.
here described na, कि one is signed or one is ones complement. In many questions we didn't check because
Hmm.
there is nothing to specified. So
Yes.
directly we are calculating, but here it is specified. That's why I was checking whether it is a negative number or a positive number. In other questions also we can somewhere we have checked, but when it is given in ones, twos or signed form, that's why we have to check whether it is a negative number or a positive number.
Okay, ma'am. And the second method that you've used, can you just give the overview for the
Uh,
A's value and B's value only?
okay, for this question,
Yes, ma'am.
okay. So what you are asking? Okay. So here the A value is given already in ones complement, right? So we are
Yes, ma'am.
not doing anything with the A. Only we are checking the B. So B is already example it is specified, right? It is a sign. It is specified as a signed number system, right? So that's why we are checking whether it is a positive or negative, because in the sign when you are checking with the slide, it is clearly written in a sign magnitude MSB is 1, then it is a negative. If MSB is 0, it is a positive. Okay. So here
Yes.
MSB is 1. So that's why I am considering as a minus. Now remove that MSB part. Okay. Now calculate its decimal equivalent of this binary number. What will you will get? Just let me know what will be the answer. That if you calculate it, you will get 26, right?
Yes, ma'am.
Just check it. Okay. So that's why here, if you will discard it, just you will add this decimal equivalent, you will get 26. Here for writing purpose, it is minus 26 in a decimal representation. Okay. But when we are going to perform actions or addition or something, so we have to take it as a plus 26. So what is a binary representation of plus 26? So just in place of 1, you have to put the 0. You will get the binary representation of plus 26. So that's why I have written here 0, 1, 1, 0, 1, 0. Representation of plus 26. Have you got who is asking the question?
Yes, ma'am. Yes, ma'am.
Okay. So now it is only binary representation. So what we need to do? A is given in ones complement form. So it is a bind. So we need to convert it into a ones complement. So here we have converted it in a ones. So 0, 1, 0, 0, 1, 0, 1. And now A is also in ones complement form and we have converted B in a ones complement form. So add these two numbers. So what is a x? X is equal to a plus b. We have got x, right? After adding x in ones complement. Now it is a ones complement form only. But here x we need to in a twos complement form. So that's why we have add in ones complement 1 in order to make it in two complement.
Ma'am, I got confused at the place that where in the most of the left
Yeah.
A and B are written now.
Uh,
So that needs to be, I think,
Okay,
change.
let what just I need to erase it and again.
Ma'am, the question is sorted. I had just, got the point.
Okay, yeah, you got the point.
Yes, ma'am.
Okay. Any other
Ma'am,
confusion? Yeah.
Yeah, ma'am. Thank you
ma'am,
so
in
much.
binary we have to just convert, means the both the numbers should be in same number system, but in decimal we can directly perform
If
like we
both
do in
are
pen
in
and paper.
decimal, if both are in decimal.
Ma'am, like in this question we have add a and b directly, that is 10 minus 26, we are getting
Oh,
minus
this
60.
this one. Yeah. This we have converted in both in a decimal number directly.
Yes, ma'am.
Okay, it is a short. I mean, you can say it like a shortcut, but you have to cross check it. I just told you this one 10 minus 26 is minus 16. What is a representation for minus 16? But you have to solve in this way. What is already told.
Okay, ma'am, got it.
Okay. Okay.
Ma'am,
Okay.
actually tomorrow also we have a problem solving session, so do we have to attend that also or just Saturday sessions only?
If you want to practice more questions, then you can attend that one also.
Ma'am, tomorrow also week one content is only practiced.
Yeah, yeah, most probably. But taken by some other student, some other person.
Okay, ma'am.
Okay. So anyone have any other doubt?
Thank you.
Okay.
Thank you, ma'am.
Okay. So if there is no doubt, we can close the session.
Thank you, ma'am.
Okay. So there is no doubt.
No, ma'am.
Okay. So thank you everyone. Thank you for attending this session. So we will meet to the next week,
Thank you.
Saturday same time. Okay. So thank you everyone.
Thank you, ma'am.
You can leave the session now.